Hello ladies and gentlemen, and welcome to Mr. Sasato's YouTube videos. Today we're going to be going over electron configurations, so make sure that you have your notes out and that you're following along with them. Alright, so we talked about orbital diagrams already, and you can probably do those pretty easily, but now we have to talk about electron configurations. Now, the nice thing is if you can draw orbital diagrams, electron configurations are just kind of a natural extension of that. Instead of using boxes and arrows, electron configuration is a numerical way to show the arrangement of electrons in an atom, and it specifically uses superscripts. So instead of up and down arrows, we're going to be using sort of superscripts. And in case you don't know what a superscript is, the 2 in x squared, that's a superscript. So how do those relate to each other? Well, superscripts are used to represent the number of electrons in each orbital. So instead of boxes with a whole bunch of arrows going up and down like that, we have just superscripts to represent those electrons. And so if you have a periodic table, take that out because we're going to be looking at neon. So neon has an atomic number of 10, and so that means that my electron configuration is going to have 10 electrons in it. So let's take a look at our energy levels and go from there. Right, so the first thing I'm going to have to do is remember the order of my orbitals. And so I have a 1s that comes first, and I can have 2 electrons in there. I have a 2s next, which has 2 electrons in it. And then I have a 2p, and neon, in order to get to 10 electrons, it would be 6. So notice that I have my superscripts up here, and my superscripts add up to 10. So I have 2 plus 2 plus 6 equals 10. So just instead of using boxes, I'm now using superscripts. It's not entirely different than orbital diagrams, but it is sort of a shorthand way of figuring out a way of representing how many electrons there are in an atom. Alright, so something that I didn't mention before, but something that could kind of come in handy is how are you supposed to remember the order of low energy orbitals to high energy orbitals? Well, I gave you that sort of memorization technique, and it does work, but something that you can use instead is just the periodic table, because I didn't mention this before. So there are actually, if we're going to be honest here, there are different sections of the periodic table. Okay, and I'm going to have to draw that little guy over there. And I don't have another color, but the f orbitals are kind of so separate from the rest that I don't think you'll really get those confused. Alright, so we have the s block, okay? And in case you're wondering why it's called the s block, it's because these elements in their highest energy level have s-shaped orbitals. And then we have the p block over here, and the p block, again, the elements in this section of the periodic table, their highest energy electrons, have the p orbital shapes. And then we have our d, same exact thing, and then we have the f block all the way down here, which all of their elements have, again, f-shaped orbitals in their highest level. So why does this work? It's kind of a cool little shortcut. It actually explains a lot about the periodic table, as we'll find out in our next unit. But each period of the periodic table is sort of represented by a number going up and down like this. And the reason why we stopped at 7 when we were dealing with numbers for our orbitals is because there are 7 periods on the periodic table. Okay. The other thing that is kind of cool about this is that the orbitals themselves are always broken up in the same way, s, p, d, and then f. And so it gives you kind of a cool way of being able to just kind of use the periodic table to figure out what orbitals something has, instead of having to kind of, just draw out all of that, sort of pattern with all of those diagonal lines that we talked about before. All right, and so just to give you an idea of what that might look like right now, we have, sort of the 1s, and so that's hydrogen and helium, okay? Then we have the 2s, and then as you move across, we have the 2p, then we have the 3s, then we have the 3p, then we have the 4s, then we have the 3d, okay, that one was kind of a big exception, as you'll find out, okay, and then we have the 4p, then we have the 5s, and we have the 4d, and it kind of goes around the periodic table in that manner, and so it's kind of a cool way of being able to keep track of all of those orbitals without having to memorize really anything. so let's draw some electron configurations. So I've got to look at carbon. Carbon is element number 6, so I have to have 6 electrons, and so I go in order. 1s, and that would have 2 electrons in it. 2s, that would have 2 electrons in it. And then 2p, that's where, carbon is found, so I have to count, and I need only 2 electrons then to get to my magic number of 6. That would be the electron configuration for carbon. Right, now let's get progressively a little bit more difficult. We've got sodium. All right, so sodium is number 11 on the periodic table, so I have to have 11 electrons by the time I'm done. So again, lowest energy first. 1s, then 2s. Then I have my 2p, and that can have 6 electrons in it. And then I'm stuck in the 3s if I am going to write the electron configuration for sodium, and I only need 1 electron to get to 11. And so that would be the electron configuration for sodium. Now let's go on to sulfur. Sulfur has 16 electrons, so I have to make sure I have 16 electrons by the time I'm done. So again, lowest energy first. 1s2, 2s2, 2p6, 3s2, and now I'm going to be in the realm of sulfur. So I have 3p, and I need to make sure I have the right number of electrons. So in order to get to 16, I only need 4 electrons. So that would be my electron configuration for sulfur. All right, and so last but not least, we have manganese. And so manganese is Mn, not Mg, in case you mixed those up. And so manganese is number 25. So I have to make sure I have 25 electrons. So again, lowest energy first. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and now don't get confused. Remember, the next energy level up is actually 3d, and now I have to make sure, since I'm in that realm now of where manganese would be found, I only need 5 electrons to get to 25, and so that would be the complete electron configuration for manganese. And so that's absolutely everything for electron configurations. You can try out some extra ones for practice if you need to, but other than that, that's it. So if you have questions, make sure you ask tomorrow.